Hello everybody, welcome back. Today we're looking at 2.5 using the sine and cos ratio to calculate length. So in the previous lesson we learned to calculate the angle. Now we're going to go back and start calculating the length of one of the sides. And we did this when we did the tangent in 2.2. So it's very similar to that, only now we're going to be given the hypotenuse, and we're going to look at using sine or cos in order to determine what we have. So it says example 1, using the sine or cos ratio to determine the length of a leg. So in this case we're looking for BC. We're given 50 degrees, which is C, and we're given the hypotenuse, so we're looking for BC. So the line, the length from B to C is the adjacent side with respect to 50 degrees, so we're looking at the cos ratio. Okay, so let's plug in what we know. We know that we have 50 degrees, so you can just put 50 in there. It's a good habit, like I said, to get into putting the what happened there, my bad. You should put the 50 degrees in there. Again, your calculator, you don't need to put the degree symbol in your calculator, but you have to show that you're putting the degrees in, or you understand that it is degrees, right? The adjacent side is B to C. You can call it X or B to C, it doesn't make a difference. And the hypotenuse is the side opposite right angle, which is 5.2. Leave the units up for now. So in order to solve for this, we have to multiply both sides here by 5.2. So that will give us multiply both sides by 5.2. That's going to give us 5.2 multiplied by the cos of 50 degrees, and that's going to equal the line segment BC. And that's really all that's to it. So now we just got to plug it into our calculator. I'm just going to put BC on this side. Not that makes a difference. BC is equal to, so on your calculator you're going to go literally 5.2. On mine, I don't have to hit multiply. As soon as I hit cos, it's going to multiply. It's going to open up a bracket, 50, close my bracket, hit enter, and I get 3.34249. Not that makes a difference. It's 1/10 of a centimeter, so the 4 leaves a 3 out of 3. So your final answer is going to be the side BC is equal to 3.3, and then look at your units. It was centimeters for the hypotenuse, so it's going to be centimeters for the side length, and you are finished. So the length of B to C, that line segment, is approximately 3.3 centimeters. So that line, or the side BC, which in this case was the adjacent side information that we have, is equal to 3.3. And that is literally it. I guess I could have put a diagram in for you. I'll do that now. So those of you that may be still struggling, saying, okay, I'm not sure of the opposite side, remember, they gave you the side 50. You had the hypotenuse, which is a cross, so I label hypotenuse, or HYP. The side opposite of angle C, and that's the adjacent side to angle C. We didn't use angle A because we don't know what it is. I know a lot of you said, well, it's just 40, sir. But why not just use the given angle? Okay? But you could use sine and use 40 degrees to get the same answer, but not necessary. You're going to try one on your own here on page 15. Check your understanding. Determine the length of PQ to the nearest 1/10 of the centimeters. Complete it the same way. Let's look at example 2. Example 2 says using sine or cos to determine the length of the hypotenuse this time. This one has a few more calculations, but it's no big deal. So if you want to label your triangle, you can. It's a good habit to get into if you wish. Okay, so maybe I'll do the labeling of the triangle right now. All right. So the labeling of the triangle will look like this. So we have the given angle E is at 55 degrees. So we'll go opposite of 55 is 6.8. So I put opposite here. Hypotenuse is what we're looking for. And notice I call it lowercase f. I mentioned that in one of the earlier videos. Instead of calling this length E to F, they'll just call it lower D, which means it's across from upper D, right? So lowercase is the side length, opposite of the uppercase angle. Again, it's completely up to you how you want to look at that. It doesn't really make a difference to me. how you label it. I recommend this way here, but it's up to yourself. So as you can see from our labeled triangle, if we are given the opposite side and we're looking for the hypotenuse, we're obviously going to use the ratio that has opposite and hypotenuse, which is sine theta. So now we're going to fill it in. All right, we'll fill this in. So the theta is obviously the 55 degrees. I'm going to get that degree symbol from the last question. All right, so it's going to be 55 degrees. And the opposite is 6.8, so I can fill 6.8 in for the opposite side. 6.8. And hypotenuse is what we're looking for, and we're going to call that lower f. Okay? Call that lower f. Instead of calling it DE or ED, we just call it lower f because it's opposite of the upper f. And it's fine. It's either way. So to solve for this, we're going to multiply both sides by f. So multiplying both sides by f, we get f sine 55 equals 6.8. And then we divide both sides by the sine of 55 degrees. Just don't even find a decimal here. Just leave it as you see it like that. Divide both sides here, and we end up with f is equal to, we're going to need a fraction because we're dividing this, right? So the numerator is going to be the 6.8, and the denominator is going to be the sine 55. So I've just rearranged this, or like I told you in an earlier video, the f and the sine 55 degrees, they can just interchange positions, whatever is easier for you. So on your calculator, make sure you use some brackets here. So it's going to be 6.8 divided by, open up your bracket, sine 55, close your bracket, and we get 8.3. Oh, sorry about that. We get 8 decimal. And I just take a few places after decimal because it's usually going to get us around to the 10th or the 100th or the whole number value, right? So it's going to be 8.30126. I just grab a few values, right? So we go f is equal to, and it says to the nearest tenth of a centimeter. So the 0 leaves the 3 out of 3, and it becomes 8.3, and the units, of course, are centimeters, as I just mentioned. Okay, so the length of DE So the length of DE is 8.3 centimeters, right? Because it is the same. Length DE is equivalent to F. We just use F instead of having so many variables in there. Again, it's just preference. It's not a big deal. Whatever you're comfortable with. Okay. And then next, what we're going to do is there's an example there, or a check your understanding question there for you. I'm going to take this up. And we'll do the final example for this section. All right. It says solving an indirect measurement problem. The surveyor made the measurements shown in the diagram. How could the surveyor determine the distance from the transit to the survey pole to the nearest 100th of a meter? I'll make that a little bit smaller for us so we have a little more room. Okay. And what we're going to do is we're going to, I'd pull out the triangle and maybe label it. It's up to yourself. You don't have to, but some people like to draw a clearer image of just the triangle. So I'll do that now. So there's the image that you have. I've taken it, and it's the same thing really. I just a little clearer, I guess. So in this case, we have the angle T. We have the side adjacent to it, and we're looking for the hypotenuse because we're looking for the distance from the T to P, right? The distance for the surveyor, so for the transit to the survey pole, that's what we're looking for, which is the hypotenuse. All right, so what we'll do is we're going to use the cos ratio this time. And again, the reason we're using the cos ratio at this time is because we have the adjacent side, 20.86, and we have we're looking for the hypotenuse. Okay, so we'll do that now. So the cos theta is going to be 67.8 and it's 3 degrees. Decimal 3 degrees. The adjacent side is given as 20.86, and the hypotenuse is what we're looking for. Again, you can call it x if you want. You can call it TP. It doesn't make a difference. You can call it lower S, right? It's completely up to you how you pick that, but if you're going to pick lower S, just make sure you put an S here, that's all. Okay? So now we're going to solve. I'm not going to solve this one again. You know how to do it. Remember, you're going to multiply both sides by S, divide both sides by the cos, and you're going to end up with S equals, we'll need a fraction, and 20.86. That has not changed. And then the denominator is going to be cos of 67.3 degrees. All right, so we're going to calculate that now. So we get 20.86. We're going to divide that by, open up your bracket, cosine 67.3. Close your bracket, hit enter, and end up with 54. 54.0546. It says to the nearest hundredth of a meter. So the nearest hundredth of a meter is going to equal the 4 leaves the 5 at a 5, and there we go. So we're being quite exact here, right? Because hundredth of a meter, that 5 is actually 5 centimeters. Right, so it could be a big difference when you're talking survey, right? And we'll answer the question with the sentence. So the distance from the transit right here to the survey pole, which is on here on the other side, is equal to approximately 54.05 meters. Okay? There's a check your understanding question that goes along with this. You'll see the answers provided here in brackets. They have given a diagram for you. The homework questions involved in this section are on start at page 101, and they're numbers 4 through 11. So that's it for section 2.5. In the next video, we'll start with 2.6. I hope everybody enjoyed the video and it helps out with some of your understanding. Thank you very much, and we'll talk again soon.